Okay, so welcome back. And so what we're going to do is, in this example, we're going to look at, hey, what happens if our interval that we're integrating over includes where the two graphs switch, okay? So, for example, in this case, sine and cosine over the interval 0 to pi. So that's the region that we're interested in. So I kind of sketched the graph here. So this is the area that we're interested in. Notice that the sine curve switches right here, right? So we need to find out where that intersects. Okay? So where does sine and cosine intersect? Okay, now if you don't know, you have to figure that out, right? And again, on the exam, you're not going to have your calculator. Okay? So what angle is sine and cosine the same? Okay, well, that's where you have to go back to your unit triangle, right? Well, the only triangle where you're going to have the same possibly is going to be the 45-degree angle, which is this one. So sine is going to be opposite over hypotenuse, and the cosine is going to be adjacent over hypotenuse. And so both of those, you get the same result, right? So the answer is going to be the 45-degree angle, which is what? Pi over 4. Oops. Right? Pi over 4 is for the 45-degree angle. So now we have two intervals. So what we're going to have to do is we're going to have to split this up into two intervals that we're going to have to consider. Okay? So the way we're going to do this is, first of all, we've got to, let's see here. Consider, obviously, the absolute value. So again, we're going to set up the interval, right? So again, A equals the integral from 0 to pi of, now the function on top is going to be cosine, but it doesn't matter because we're going to put the absolute value signs in there. So it's going to be sine x minus cosine x with absolute value signs. Okay? And so with that in mind, we're going to split it up into two intervals. Which means if we're going to take the absolute value of this, that's the same as just doing cosine over sine if we're dealing with this interval. And then over here, we're going to do cosine over sine, or cosine minus sine, or excuse me, sine minus cosine. Okay? Because again, we want positive area. Okay? So again, there's different ways of doing this, but we're dealing with the absolute value of sine minus cosine. But this time, remember, we're going to split this up into two intervals now. We're going to go from 0 to pi over 4. And we want the absolute value of sine minus cosine, but which one is on top? Well, cosine's on top. So the absolute value of sine minus cosine would be what? cosine x minus sine x. So we can drop the absolute value signs if we just switch the order. Right? Top minus bottom. And then we're going to add to the area from pi over 4 to pi, but now sine is on top, so we're going to switch it to sine x minus cosine x dx. And so as long as we get positive values, right, that's what it means for the absolute value. We want the positive value of the integral. And so now if we integrate, what do we get? We get what? Sine x, right? The integral of cosine x is sine x. The integral of sine x what? So we would make this positive because if we have a negative, we make this positive negative. The integral of negative sine x is cosine x because the derivative of cosine x is what? Negative sine x. So this is going to give us plus cosine x evaluated from 0 to pi over 4 plus, and then we're going to do the same thing here. So again, here we have sine x. This is going to give us what? Negative cosine x. And here it's going to be minus sine x from pi over 4 to pi. Okay, and now all we have to do is evaluate this. So let's do that. So this is going to be sine of pi over 4 plus cosine pi over 4 minus sine 0 minus or plus cosine 0, right? And then we're going to add the same thing. So, or actually, let's pull out the minus. We'll make it minus so we can factor out the negative 1. Minus, we'll say, again, I need a bigger brace here because I want to subtract the whole thing. So it's going to be cosine oops, wrong one. I was going to say pi, not pi over 4. Pi plus sine pi minus, again the same thing, cosine pi over 4 plus sine pi over 4. Sorry, I'm writing so small. So again, you're just evaluating this. Again, this is stuff you should know how to do. So then all you have to do is put in what is the sine of pi over 4. Okay, well the sine of pi over 4 is, like we said, 1 over the square root of 2, or square root of 2 over 2. Cosine of pi over 4 is the square root of 2 over 2. Minus sine of 0 is 0. cosine of 0 is 1 minus, what do we get? Cosine of pi. What's the cosine of pi? What? Negative 1, right? So cosine of pi is negative 1. Okay? And then sine of pi is 0. And then cosine of pi over 4 is square root of 2 over 2. And plus pi over sine of pi over 4, which is square root of 2 over 2. Okay? And so when you simplify all this, again, take your time and you simplify all this, what you're going to do is you're going to get the square root of 2 over the square root of 2 times 2. Hold on a second. Did I? Yeah, that's right. Yep. Yep, that's right. So then what you end up getting is your final answer is, where's it at? Two square root 2 is your final answer. Again, just take your time, make sure you put in the correct answers. Apologize for my chicken scratch at the bottom there, but I wanted to give a little bit more detail than what the textbook does. Okay, so here's one for you to try. So let's say you have the region R, and it's bounded between, let's see, it's bounded between these two functions. And we want to do the over the interval of this interval. So find the region of R based on that. So that's what you can do. And again, just let me know if you have any questions or if you want me to confirm your answer. Take care.